Excellent. So, welcome to this masterclass or webinar that is today going to be focusing on tinnitus research, and especially on a molecule which has been researched or investigated in the last few years, which is called AC102. And today I will try my best to help you understand how this molecule works, but also let you understand the time frame about when we can expect to get these drugs potentially in the market, but as well talking about um, the current utilization and when this drug can be used and the way this drug works, meaning that what in terms of physiology, where is this drug acting and what is it currently doing. During this presentation, I hope to make it as interactive as possible. And the goal here for me is going to help you to understand how the hearing organ work. So helping you to understand new research, but also identifying tinnitus strategies that can help you in your personal journey. My name is Fabrice Bardy. I'm an audiologist, also a hearing scientist. I spent 10 years of my life doing auditory neuroscience. And it's actually a very interesting for me to sort of talk about research because it's something which is close to my heart. Um, so initially, during the presentation, we will look at tinnitus cause, and we're going to see that tinnitus can be caused by different things. Is a variety of cause, and it's really important to understand that the cause, understanding the cause can help us to also identify which treatment is going to be the most useful for you. We're going to talk about associated symptoms because it's also complex and it's impacting us all in a different way. And it's going to be hopefully helping you to understand that also how we can basically treat and get access to treatments that help us with the symptom associated with
Doesn't work.
tinnitus.
No sound.
Uh, Sorry, someone was talking. It seems to be all good. Then we will talk about this new research, which was published in May 2025. So it's like 2 months old about this new molecule AC102. It's some research which was completed in animals, in the rats or jobile are generally used. And then they are I will talk about the different stages in clinical trial, and then to help you understand also when we can expect to get these drugs, how this drug is working. And
I can't
lastly,
hear
we will talk
anything. What
about.
good is it?
Well, you need to hear it.
Oh, sorry, Brian, it looks like you're having issue with your sound. Hopefully, everybody's able to hear me correctly. In case you have issue, please, you can write it inside the chat.
Video, how come you got it X'd?
I'm sorry about that. So before we start the presentation, I would also like to tell you that inside the Zoom platform, there's a possibility for you to use captions. And to use caption, you have something on your screen where it is, let me get back here. So on your screen, you will have something which is called CC, captions. So there's a button where you can basically click on, which allows you to get access to caption, which can be useful during the presentation. So feel free to use caption. And the other thing that I wanted to say is that there
hit them more.
There is also a Q&A section a chat where you have the possibility to write question in case you have question during the presentation. And we will have breaks during the presentation where you will be able to ask your personal question.
Second, they go
And
back,
if you,
check.
I'm
Push that one
going
up.
to need to sort of. So I'm sorry, but I will need to sort of like try to. Mike is currently having an issue with his microphone. So here you can write your question. Great. So inside the chat, you will be able to ask your question during the presentation. As I said, I will try to answer as many as possible. So let's get back to the presentation. And here, as to start, I would like to talk about the different tinnitus cause or what can cause tinnitus. And you can see here on this screen that there's a lot of variety of different reasons why we can develop tinnitus. We see that often it can be linked to hearing loss or hearing damage, and we would talk a lot about that today. Some of you might have developed tinnitus because of exposure to noise, but in certain cases can also be linked to some stress episode in our life. Can be linked to age, and age is a confounding variable in the sense that it's a link to hearing loss also. Head injury or head trauma can also cause tinnitus, as well as medication, certain medication, ototoxic drugs, for example, during cancer treatment. And then there's certain disease or like infection of or wax inside the ear canal that can be causing tinnitus. Now, I just launched a poll or a quiz, and then I just would like to sort of like ask you all to be able to participate to the quiz in order for all of us to have an understanding of like the distribution of like all these different causes. And you're going to see that today, the drugs that we're going to talk to is can only be used in certain cases, in certain circumstances. But we will also talk about other research that can be, that work on other treatments that can be targeting other cause of tinnitus. So thanks a lot for engaging. You can click on multiple causes in case you feel that it's not only one thing that is caused your tinnitus. And feel free also to write in the chat in case you don't know exactly what caused or what made that your tinnitus started. So we have 60% of you already answered. I give you another minute, and then I will share the result with you. Then it's going to give us like a sort of like indication about what is the distribution around all these causes. Understanding the cause can be, again, important. If it's stress, then we will add different strategy in order to sort of like provide treatment than in case it's like hearing loss related or noise exposure related. So great. So 80% of you have now responded. And I'm going to wait another 5 seconds and then I will share. Great. Thanks a lot for participating to that. I will share the results here. And you should be able to see that on your screen. That is like a very wide distribution. So there's like currently 26 people in this room, but we can see that the symptom, the cause which is having the largest percentage of participants is exposure to loud noise. And so this is something that is very common. 43% of you have been experiencing that. In the case of exposure to loud noise, we will see, especially in this presentation, that it can have an impact on the cochlea and especially on the synaptic connection. And we will talk about synaptopathy today. And it's like when we get a little button, which is basically not functioning anymore correctly. And in these cases, you will see that the research that we are going to talk about today, it's very much linked. So the drugs that we will basically talk about, which is the AC102, can have a positive impact in case of exposure to loud noise. So that's and we will see certain condition when it's when this drug can be delivered and what is the optimal window to deliver this drug. We can see that hearing loss is another, and it's a second causes in terms of percentage here. 38% of you indicate that hearing loss is linked to the tinnitus, and it's in some case, it's very, it's not surprising in the sense that the hearing sensation is coming from a damage inside the hearing organ, and we will talk a little bit about where this damage can appear. And then we have like a wide distribution of all the symptoms. Temporomandibular joint disorder, which is like in the case of tension in the jaw, tension in the neck, can also be linked to tinnitus. Ototoxic medication, we talk about, there is like different aspirin, could be, for example, high dose of aspirin could, in certain case, have an impact on tinnitus mania. And acoustic neuroma, which is also very rare, but is a very benign tumor, also a tumor on the auditory nerve, which can develop and which can cause tinnitus. And then in certain case, a static tube dysfunction. A static tube is basically a small tube that is linking the middle ear to the mouth, and then it allows us to equalize the pressure for the ear membrane. If this little tube is blocked or squeezed, then it cannot do its job to equalize the pressure, and then it can then have a link on the function of the ear. So you can see that, and stress and depression, which is 10%, and we can see in certain research that it can even be a higher percentage of people who can have stress and depression as a cause, or a starting cause for tinnitus. So you can see that it's very widespread of different potential causes, and the thing which is really important to acknowledge is that tinnitus can then impact us in different ways. So more than the causes, tinnitus can create stress. Tinnitus can create sleeping difficulty. Tinnitus can create anxiety or depression. And tinnitus can also then be linked to some hearing loss, meaning the hearing loss can also have some impact on our communication. So in this next question, I would love to hear about how tinnitus is currently impacting you in your life. And so let me start. I'm launching another. So you can see like on this board, now I would like to understand more than the cause. It's like, how is it currently impacting you? So is it increasing your stress level? Is it impacting your sleep or your concentration? How is it really? So you're going to see that it's a slight difference, or is it impacting your hearing in the sense that you then have the hearing difficulties? And thanks a lot for participating again. This is really helpful because it's going to help me to understand your current situation as a group. And then I would going to talk a little bit more about a certain aspect, and especially in the last part of the presentation, where we will talk about strategies that you can already use in order to minimize the impact of tinnitus on your life. Great. So I'm going to stop and show the result again. And you can see that, not surprisingly, negative thoughts is actually currently the main impact, or like one of the negative thoughts that worries, for example, that the tinnitus is going to get worse, or worries about how this is going to impact us in the long term, is like the number one consequences of tinnitus. Then you can see that stress and anxiety, these worries can often generate some stress. The more we worry, and the more we're going to be uncertain about what's happening, and the more it's going to create or stimulate the brain and the emotional brain, and they make us feel worried or stressed or anxious. And it's also something which is very common. And we're going to see, so from a research point of view, the treatment option, and when we look at the efficacy of different treatment options, we know that cognitive behavioral therapy is a strategy, the number one strategy, or the strategy that the largest amount of evidence for its efficacy. And what it means is like, and we're going to see that again in this last part of the presentation, that there is today strategies that you can use in order to minimize the worries, which can then have a positive impact on about how you feel and decrease the distress that can be that can be caused by the tinnitus. Feeling depressed and sleep, 55% of you have feelings that you're having sleep issue. And then negative impact on your work, your productivity, and your concentration. So it's also like another like very significant, a very significant proportion of you impact in this way. And then neck and is like meaning creating the tinnitus can create some tension in our body, and this tension in our body can then have an impact on tinnitus. There is inside the neural pathway from in the brainstem, there's some connection between the nerve termination from the jaw and the auditory pathway, and it's one of the reasons why it's kind of have an impact. But yeah, so I think it's hopefully it's helpful for you to see that tinnitus is complex, but it's really important that we are impacted in a very unique way. And sometimes when you talk to someone else who experienced tinnitus, the symptom and the way it's going to impact them is going to be very different. But today, what we will talk more specifically about is really around hearing loss and cochlear dysfunction. And we're going to see that this new research shows that there's a possibility to have an impact on how the auditory connection in the neurons which are connected to the cochlea can potentially be protected. But first, I would like to give you like a quick overview about how the hearing organ works. And you will see the pinnae, which is like the external ear, which you all will know. And the sound goes inside the ear canal. And then we get something, the eardrum here, which is capturing the sound, transmitting it through like 3 small ossicles to the cochlea. The cochlea is like it's an organ which is like a snail, and we're going to see how it's working a little bit more, but it's linked to the vestibular organ, and you get the 3 semicircular canal here, which are basically here as our balance organ. And the cochlea is going to capture the signal and transform the acoustic waves into an auditory signal inside the auditory nerve, which is basically in yellow here. And then the signal is going to be transferred and transmitted to the auditory brain. So this is a brainstem that we call, and it's going to go up into the auditory cortex, which is based inside the temporal area here. And this is where the perception is going to happen. So here's like a short video which shows how the sound comes, so the vibration entering the auditory canal, making the eardrum move, so ossicula moving, then it's basically transmitting to the sound into the cochlea. And then here is another view, which basically shows the auditory nerve in yellow. And the auditory nerve is where the signal is going to be transmitted. It's where we are going to specifically look today for this research, which has been completed. So the cochlea, it's like a snail, and it's a very tiny organ. It's 3 millimeter in diameter, so it's super small, super tiny, and it's organized like a piano. So inside these organs, you have like, try to imagine a piano, and you get the high frequency, which are located at the apex, so at the bottom of the at the bottom here of the cochlea, so all the high frequency, and the higher you go inside the cochlea, so you can see when you go inside the spirals, then you're going to get into the low frequency. The high frequency are the one which is closest to the oval window where the sound is going to be transmitted. And it's one of the main reasons why high frequency hearing loss is like a normal aging component. So like with age, the high frequency gets more stimulated. And then you're going to see that there's some hair cells that can then disappear, and then the signal is then not transmitted to the auditory brain. This is the cochlea, but if we cut the cochlea in two, and you're going to see so that the structure of the cochlea, where there's something inside, which is here the organ of Corti, and inside the organ of Corti there is something which is called hair cells, and these hair cells are going to capture the sound and they're going to transmit the sound then up to the brain. This hair cell, so on the screen now you can see hair cells, and these hair cells have a V shape. And you can see that with aging, unfortunately, this hair cell can disappear. We have a discrete number of hair cells, so there is 13,000 hair cells, inner hair cells inside the cochlea. So it's quite a low number, if we think. And then with age or with noise exposure, then, or sometimes medication, this hair cell can be damaged. And if they are damaged, then the signal cannot be transmitted. So here we look, these are normal hair cells. And here is in case the hair cells have been damaged, and you can see that they are disappearing. Then on the screen here, you can see an acoustic neuroma, like which was on side the auditory nerve, which can also be another cause of tinnitus. But if we get back to the hair cells, we can see here on the top left, we have normal looking hair cells. The V-shaped hair cells have what we call the outer hair cells, and they are very good. It's an amplifier. I don't know if some of you are musicians, but the cochlea is an amazing amplifier. It's the best amplifier that we will ever be able to see. So it's be able to sort of like, you are what we call a dynamic range of 120 dB. So I don't know, it's a logarithmic scale. So each time, I don't know if you, but it's an humongous dynamic range. And this is just working because of this outer hair cell, which are doing an amazing job of amplifying the signal. So this is an amplifier, if you want, here. And the inner hair cells is more like a sensory organ. So they are capturing the sound after the sound has been amplified, and they are transmitting the sound up to the auditory brain. And you can see here, so these are hair cells for hearing loss of 10 to 30 dB, where you can see basically this certain hair cell will start to disappear. And here we have like 50 to 60 dB, where there's more hair cells which are away. And then this is between 80 and 100 dB hearing loss, where there's nearly no hair cell anymore. more than the air cell, so this is like the air cell at the top of the cell, more than the air cell, we're going to see that the air cell is capturing the sound, but it's transmitting the sound up to some, and there's like here, what we call the release of a neurotransmitter, which is then sending the signal inside some neurons. And here we can see three kind of neurons because of like the loudness. So different neurons are going to encode different loudness. And when the signal is transmitted here, if there is too much, in case of, for example, exposure to loud noise, then it can be a concentration of, and generally is glutamate, which is a neurotransmitter, which is present here. And if it's a concentration of glutamate, which is too high, then it can have an impact on the neurons, and the neurons can degenerate. And then we're going to see that the drugs that we're talking about today can have an impact here on reestablishing some connection with the neurons at this level. So we will see that a little bit more. So try to imagine now again, here we have like a normal neuron, a nicely working neuron here. So this is the air cell. So there's some noise presented. The signal is then we're going to have the release of neurotransmitter, which is going to activate the neuron, and the signal is going to be transmitted into the central nervous system. In case of too much noise, what happens is like we can damage, we call that a button. We can see the termination here. We can damage because there's too much glutamate which has been released, and it can become neurotoxic, and it can basically damage this connection. And we're going to see that the drugs that we're talking about today can have an impact to regenerate or potentially help to reestablish a connection between this neuron and the cells from the cochlea. So this is a short video that explains, we see the noise, there's a stimulation, the signal is transmitted, but then because there's too much noise, then we can see that there's a tinnitus, which is start. Interestingly, the nerve is not receiving any more signal from these cells. The nerve is starting to fire randomly. And it's what basically is the sound that we hear. So the tinnitus comes from a lesion inside the cochlea. And then because the nerve is not receiving, because the nerve is not receiving any signal, then it starts to fire randomly. We call that a stochastic activity, which sorry, I'm going to restart with the sound. And I love this video. I found it quite nice. But you're going to see that this cell that we saw, some people have been able to record and do some visual recording of these cells when stimulated by a song, by an auditory stimuli. And just going to let you enjoy.
1, 2, 3 o'clock, 4 o'clock, rock. 5, 6, 7 o'clock, 8 o'clock, rock. 9, 10, 11 o'clock, 12 o'clock, rock. We're gonna rock around the clock tonight. Put your glad rags on. Join me home. We'll have some fun.
So you can see here that the cell is developing. Actually, the rhythm of the music is capturing the vibration, and then it's releasing at the bottom. Here it's going to release a neurotransmitter based on the auditory stimulation. And I found quite fascinating to be able to sort of like being able to see this sort of movements and how the cell is going to extend and retract in order to basically be able to send some signal in the auditory nerve. But yeah, so going back into the cells, basically, so this is like a normal connection, a normal button. This button can sort of like explode if you want. And if we look at the electrophysiology recording of this button, then we can see here that this is a normal electrophysiologic trace. Then when the button is not here anymore, we can see that it becomes a flat line. And then with time, interestingly, and some of you might have experienced that, you go to a concert, it's a bit loud, you wake up in the morning, your ear are ringing, and then a few hours later or a day later, then there's a possibility for this neuron to regenerate themselves. And if they regenerate themselves, then we have the possibility to recreate a connection. In certain cases, if you experience, and some of you, even now, if you go to a concert and you experience what we call a sudden hearing loss, it's extremely important to act quickly, because we know that there is already some certain drug like steroid, which can help to, from an inflammatory point of view, to reestablish this connection. The challenge there is to be able to act quickly, and meaning within 5 days. So it's really important. So if some of you go to a concert, are exposed to loud sound, then it's really important. It's really important for you to go to the emergency department of your hospital as quickly as possible. And then they will be able to give you access to some steroid, probably, and they will basically, based on your case histories, they will be able to sort of like help you. But then we know that there is already the possibility to have drugs which can help to regenerate this connection. And today, basically, this new research shows that there's a new drug, which is called AC102, which has a possibility, which is working better than actually steroid, which is currently the gold standard. And that's really encouraging, meaning that there is potentially some active molecule which could help us to regenerate this connection. So now I want to, going back and taking a zoom back, this is like neural firing inside the auditory nerve. And in case of no sound, there is actually what we call some random firing inside the auditory nerve. And so very normal things. And it actually allows the nerve to, even in the absence of sound, we get the presence here of like stimulation. And we call that stochastic activity. So now in this diagram, why I had like multiple line is because we try to imagine each line is representing one of the air cells. And so each of the air cells are going to fire. Now let's try to focus on one air cell. And so, for example, this is a stochastic activity in one air cell when in the presence of no sound, so in silence. And we can see this random firing here. Now, if we hear the word trees, then you can see that there's going to be the random firing, but we're going to have an increased firing, and we got some synchronicity. So the neurons, and you saw like this cell moving, it follows a time structure, meaning that the neuron is going to start firing depending to the acoustic stimulation. And you can see like for the word trees, and it's going to be more firing during the presentation of the word than there is in the presence of silence. So this is like in the case of a normal ear. And there's this last one is basically the sound that we will hear in the case of cricket. And you can see in the case of constant cricket, then you're going to get this random firing with a density which is higher than in the presence of sound. Now, in case there's a degeneration and what we call cochlear synaptopathy, which is like the synapse which is not working anymore correctly, then we can see that in normal hearing, in the presence of silence, in the case of hearing loss, in the presence of silence, we get a slight decrease of the stochastic activity. And in the case of tinnitus, then the neural signal is going to be sent, there's going to see more activity that is going to be transmitted inside the nerve, and meaning that we can hear the sound. And we can hear the sound even if there is no the presence of external sound. So hopefully it helps you to understand a little bit about how the ear function. Some of the case when there can be like a ear damage, a damage inside at the nerve level after the cochlea, and how this can be represented inside the auditory nerve. The consequence of like stimulation, auditory stimulation, ototoxic drugs or aging is that with time we're going to lose some hearing. And I don't know, some of you might already be quite familiar with this representation, but you can see an audiogram here with the low frequency on the left here, low frequency 120 hertz. The frequency is expressed in hertz. And the more we go to the right, the more we go to the high frequency. And then on the y-axis, we get the hearing loss expressed in decibel of hearing loss. And you can see that what we consider normal hearing for all frequency is when we hear between 0 and 20 decibel hearing loss. And with age, you can see that we start develop a hearing loss in the high frequency, so in the 4 kilohertz, in the 8 kilohertz. We can see that at 20, for a person who is 20 years old, then we can start to get like at 8 kilohertz, and then 40 years old, then is going to be around. This is a mean. So the mean of a population of 40 years old, and generally for an average 40 years old, then is going to be like a 35 decibel hearing loss, 8 kilohertz. And then with age at 60, then you can see that our sensitivity, ability to hear high frequency is decreasing. And often it's linked to this degeneration of the auditory nerve. And then the loss of these hair cells, which are not then transmitting the signal anymore at the base of the cochlea. This can cause a hearing loss, which can potentially then create communication difficulty, but then it can also cause a tinnitus. And the tinnitus is just the perception of this random activity inside the auditory nerve. And now we're going to talk more about like this research, which was then published on the 27th of May, 2025. So it's very recent. But before that, I would like, if there's any question, I think that will be a good time to sort of like, for me to answer your question before we start talking more about the research. So let me open the...
Yes, I have a question about somatic tinnitus. Did this help somatic tinnitus? Because it's not mine, it's just muscular neck. It's causing my tinnitus. And I'm just not sure. Well, the pill itself is probably for standard tinnitus. Is that right?
That's correct. And I'm going to talk more about that. But if you have... if you use a Mindy app, so we have like masterclass, which talk specifically about somatic tinnitus, exactly what you were mentioning. So releasing tension in the jaw and the neck can help with this particular subtype of tinnitus. And this presentation by Dr. Anne-Marie van der Waal is something that I would recommend you to watch. It's talking specifically about somatic tinnitus. But it's true that today, this molecule that we're going to talk about is really at the level of the synapse, what I explained just earlier. Yeah. But thanks for your question. And I'm going to read. So someone is asking if you will recommend the utilization of Q-tips, and generally not. So like it can create wax. It can basically push the wax in the ear canal, and generally it's not something that I will recommend. It's better to gets to an audiologist or an ENT, we will be able to generally wash the ear using some water or microsection, and it's generally the best way to remove wax. So yeah. When do I get to the trial on? When do we get to the trial? So we get now. We're going to. I've heard all this stuff said. Okay, sorry for repeating, but I think it's like I like to introduce the concept before we were going into talking about this research more specifically.
Can I ask a question? My name is Ray. I have
Hi, Ray. Yes.
My right ear. I had sudden hearing loss, complete. My left ear works just fine. And what I've been reading, this AC102 is something that might well be targeted for someone like me, but I am in the United States, and everything I'm reading is all in Europe. How do I go about getting or talking to someone here who hey, look, I'll be the guinea pig. I've had tinnitus now for 3 years. Solid.
Yeah. Thanks a lot, Ray. And then we will talk about that. And so the clinical trial, but I will also talk about research more generally, and then as a timeline. So it's really important for you to understand the timeline when we talk about new drug development, because it's really important to have hope and to understand that there's new treatments available. It's also really important to understand the time frame about when these things are going to be available. So I'm going to talk about all these things in the coming slides, and hopefully it helps you to understand when you can expect to get access to this sort of treatment today. And it's really also understanding when this treatment can be used. Generally, you're going to see that the recommendation are like, and we are far to be at a phase where this drug is going to be released, because we are in phase 2 clinical trial where we are using the drug. The safety has been, and the research that we're going to talk about today is the research that did in animals. So it was in jabiles, which are small rats. But it's going to be important to get realistic expectation about all that. So hopefully I answer all this question, and if you have more question at the end, then you can ask again. Any side effects that were found with AC102, and then we will talk also a little about side effects. Can you amount of hair cell? So there's a possibility in seniors. And you're going to see that there's objective measures. And one of the objective measures that we can use in order to understand the health of heart hair cells is something called acoustic emission. So it's a probe that we put inside the ear, and that allows us to understand how the hair cells are functioning. So it's a very good measure. Not every audiologist have access to this equipment, but it's something which can basically help us to understand the healthiness of the outer hair cells and inner hair cells. And a question by Sally, which is asking, does the AC102 work on tinnitus caused by stress or loud sound? So what they're basically investigating in this research was the impact of this drug for people who had been exposed to loud sound, meaning that at this stage, it was not for stress, but we will also talk a little bit more about that. Do you have any experience with stem cell therapy? And so it's something that I wanted also to sort of touch a little bit, but gene therapy is something which is showing very promising results. Gene therapy works slightly different to this drug, whereas it's a molecule which has some property which are anti-inflammatory. Here, gene therapy is in case, for example, of what we call acquired hearing loss, for example, or genetic hearing loss, where there's certain times your genome is going to have a mutation where it's not going to allow you to encode a certain protein, for example. And certain proteins are extremely important in the hearing organ in order for the air cell to transmit the signal. And we're going to see that this year, actually it's like now 16 months ago, the first gene therapy was applied successfully in the UK, or like was a clinical trial again in the UK, where they were able to modify the gene of a specific gene. So the importance here is to understand which gene is not working properly, but they were able to sort of like modify the sequence of the genome and being able for this person to reactivate the production of a protein, which was then allowing the person to hear again. That was very spectacular. And I think it's really very exciting to see like all this research which is currently going on and which basically really provide hope about how do we basically or develop a cure for tinnitus. So let's go now. Thanks a lot for asking your question. And let's go now on the research more specifically, and hopefully you will have also more questions afterwards. So this research is in animal. It was published only a few months ago, 2 months ago. And I just want to give you like a time frame. So I think it's really important to understand time frame when we see clinical trial, and if you see news in the journals, what does it mean when you see like new and it means that the drug is going to be available already today, or what does it mean? So generally, the first phase is drug discovery. And this drug discovery can take from 3 to 5 years, where, for example, in this case, is a small molecule which has been developed. And it took them more than that, actually, more than 5 to 6 years to develop this molecule. And then they will need to find candidate who have good potential to work, and then try this candidate in animal studies. So they will add some preclinical trial, and this preclinical trial basically is going to test this potential candidate on an animal, which is awfully close, which has a hearing organ, which is closely related to how the human hearing organ works. You can see that this can take from 1 to 2 years, and this was a little bit more. This research happened in 2020, so it's already 5 years ago that it happened. And then you're going to get more phase, and you're going to see that phase 1 is going to involve human. We're going to have a low number of participants, and we're going to look at safety. The safetiness of the drug, is it side effect? And was a question there: is there a side effect on the drug, or is it no side effect? And once we are sure that the drug is safe, then we're going to basically be able to try the drug on a larger population. So here we're going to talk hundreds, 50, like is here written 20 to 50. It can be already start to be hundreds of people. Then we're going to get phase 3 clinical trial, and phase 3 clinical trial is going to be the last validation, where we increase the population side before we are sure about the effectiveness of the drug, but also we are sure that the drug is safe before it's released. And then phase 4 is more going to be about regulatory works, where we need to make sure that every country is investigating or is analyzing the clinical trials that are submitted by the company who's developing the drug and before it's released in the market. So you can see that it's a very long process, and it's rigorous because we want and it's the reason why we cannot provide the drug when we are in phase in the preclinical trial is because we are not sure yet that the drug is safe to be used by people. So it's important to sort of like understand the timeline. And today, this clinical trial was a preclinical study which was done in animal. So it's a small molecule. it's a pyridoindole. So it's like, and then I'm not going to go in details about the structure of the molecule, but it's anti-inflammatory and it has some antioxidant and neuroprotective properties. And it's one of the reasons why they sort of like were selecting. It was a potential good candidate in case of nose exposure to provide access to this molecule inside the ear organ. It can be easily diffused across the cell membrane, and here is to the target hair cells are the cells that I showed you earlier, which are like inside the cochlea, the cells that are going to transmit the signal from the inner hair cells. The method here, and I'm going to describe a little bit of what is inside the paper, what they were doing. They were stimulating, so they were using Mongolian gerbil, which were acoustically stimulated with a loud sound. Then it's an intro, it's basically using a tympanic injection. So through the tympanic membrane, they're going to go through what we call the oval window. When we saw like, this is a cochlea, we saw like a bigger picture earlier, but the oval window is at the base of the cochlea here. And they're going to basically provide access to this molecule, the AC102, at the level of the cochlea. And then the gerbil unfortunately cannot tell us if they can hear the tinnitus or not. And it's where we need to use electrophysiology measurement. In the case, we use auditory brainstem measurement and a statal reflex measure in order to be able to see if they can hear the sound after the injection of the drug. So hopefully it gives you a little bit of an idea about how the trial was conducted. And in terms of protocol, in this paper, basically they had two different protocols. So they have arm A and arm B. And you can see, I'm not going to go too much in detail, but like the important aspect here is on arm A, they had 3 injections of the drug at different, so here, like the injection of the drug just after the trauma. So this is before the acoustic trauma. This is post-acoustic trauma. And just after the acoustic trauma, they were basically using the drug. Then they were using the drug 1 week after the acoustic trauma, and they were using the drug 2 weeks after the acoustic trauma. And they compared the results that they were getting here with an arm where they were actually just providing the drug once, just after the acoustic trauma. So here, the question is like, is a multiple injection paradigm more providing better results than a single injection paradigm? And then they're going to look at what we call the auditory brainstem response, so the measure, the objective measure, to see if there's an improvement in terms of hearing, but also in terms of tinnitus. For every research, so on this paper, they had one research hypothesis, which is always the question that you try to answer for any specific research. And they wanted here their research hypothesis, it was to evaluate if the AC102 may revert the development of noise-induced synaptopathy, leading to recovering from tinnitus. So that was really, like we saw in this initial part of the presentation, the noise-induced synaptopathy is basically this button which is disappearing, and the connection between the hair cell which is disappearing. And we wanted to see here the AC102 allows for the hair cell to recover and basically stop the tinnitus. And I'm going to go a little into the result of the paper, basically, and I'm going to present only the result where they had a single injection, because at the end they figure out that the multiple injection paradigm was not providing a lot of benefits compared to the single one. And what we have here like the auditory brainstem threshold. So it's like on the left is like basically the auditory threshold or the auditory recovery after hearing exposure. On the right side, we will talk about it a little bit later. It's like the tinnitus, the tinnitus measure. So on the left side here, obviously you can see my mouse on the screen, but you can see different frequency. And then it's like just after the noise trauma, 1 week after the noise trauma, 2 weeks after the noise trauma, and 5 weeks after the noise trauma. In orange, you can see the result for the AC102. And for the black line here, it's a control. And the control was basically getting injection, but with basically just water, no active component there. And what we can see here is what we call a shift, a threshold shift, meaning that for the different frequency, 1 kilohertz, 2 kilohertz, up to 16 kilohertz. And the threshold shift meaning that at 4 kilohertz, after the noise exposure, we could see that it was a 15 dB hearing loss. And we could see basically for the two group, just after exposure, for the control group in black and the AC 102 group in orange, that the threshold were quite similar. And over time, they were trying to see if the drug was basically helping for the threshold to recover. So when it gets to the baseline, when you can see after 5 weeks, we were close to baseline in the sense that it was not anymore any hearing loss after 5 weeks and the injection of one time of the AC 102. So, and if we compare to the control, here we could see, and these stars are meaning that it was a clinically significant difference. And it means that the group who did not receive the drug was still having like a hearing loss of 5 decibel following this noise exposure. And this was across nearly all the frequencies, so from 1 kilohertz to 16 kilohertz, where the group who received the drug was basically able to recover and to a point where like no hearing loss was detected using the auditory brainstem response. It was pretty promising. And then the second thing that they wanted basically to investigate was what is the effect of the drug on the tinnitus. And the way they've been able to measure the tinnitus was using a measure which is called the gap repulse inhibition of the acoustic state, also GPIAS. And it's something that allows us to have an indication of the number of subjects which are having tinnitus at different moments. So like you can see, just after the acoustic trauma, we had 9 out of 15 animals who had tinnitus based on this measure. In the control group, we had 8 out of 13. So around 80% of the animals were experiencing tinnitus just after the acoustic trauma. And you can see that 9 out of 15, it means that we are all not equal. So and same for human, some people are more sensitive to noise than others. So some people will be more impacted by the exposure to noise than others. But it's not every animal who are going to experience tinnitus after exposure to noise. But yeah, it's like here for 9 out of 15, we are more 65% of them are experiencing tinnitus. And then we look after week 1, after week 2, and after week 3 to try to see the proportion of animals who have tinnitus. And you can see that after 1 week, only 3 out of the 15 animals were experiencing tinnitus, where 11 out of the 13 were experiencing tinnitus in the control group. And this was significantly different at week 1, week 2, and week 3. Week 2 and week 5. And at week 5, in the control group, 11 out of 13 subjects were experiencing tinnitus, and only 1 out of 15 were experiencing tinnitus. So these results are encouraging, and it basically shows that the delivery of the drug very quickly after the hearing, the noise trauma, is able to help the synaptopathy or the nerve to basically recover. And I think that's sort of like a very encouraging result. Now, they have, and I looked into their website. So in 2021, they completed the phase 1 of their clinical trial. And it's demonstrating that the AC102 is safe and tolerated by humans. And this was basically, it's something that we can find online. So it's accessible there. So the clinical, and this is more the protocol. The result have not been published, but the protocol of the study is accessible online. And now what is currently ongoing for this drug is like they are in phase 2. So they are basically doing a clinical trial on 200 people. And Ray, you're right, this clinical trial is currently happening in Europe, in different countries, including Germany, Poland, and there's a few more Eastern Europe countries, where they are trying the drug on 200 people who are experiencing moderately severe to profound idiopathic, meaning idiopathic means that we don't know the cause, but which is sudden sensory hearing loss. And so here, what they are doing inside this clinical trials, they're looking at the efficacy, and they're comparing the efficacy of AC102 and comparing it to like the glucocorticoid. So the corticoid generally is currently the gold standard in case of sudden hearing loss. And what they are doing here is like they're comparing the effect of this new drug compared to current gold standard. So hopefully it's give you a little bit of a timeline. Here is the sort of is the paradigm or the protocol of the current control trial, which is ongoing with human. And you can see here, so patients are randomized at the start when they are recruited. They need to be recruited within 5 days after the onset of the symptom. So it's really, really critical here. And you see that it means that it's a very particular group of people, but particular group of people who have been exposed to noise and who are then having certain symptoms. And you can see that in the first arm, then the people get intratympanic injection, and they are going to get some monitoring at day 7, day 14, day 28, day 56, and then another one at day 84. What's this human trial going to do? Like for human, we can do pure tone audiometry. But the thing that I was talking about earlier is called autoacoustic emission test. And this test, which can be used in order to look at the healthiness of the heart air cell inside the cochlea. And then the tympanometry, it's more like looking at the healthiness of the tympanic membrane. So we look if the tympanic membrane is moving correctly. The phase 2 clinical trial, and it's here like some of the main inclusion factors. I think it's really important to understand what they are doing. So severity means like the hearing loss need to be more than 65 dB. It needed to be within 120 hours, so 5 days after the start of the, so within 5 days after the start of the symptoms. And if they were not accepting anybody who have conductive or combined hearing loss, and then anybody who has been already taking any glucocorticoid or use some, so hyperbaric oxygen is also another way to sort of to get like help the hearing organ to recover. So that's sort of like hopefully help to understand a little bit. And so once they will, so next phase, this the clinical trial of phase 2 is probably going to be published within 2 to 3 years, probably. You could see that the result of the preclinical trial were only published this year, so it takes time before the researcher analyze the data and then publish the data in a scientific journal. And then afterwards, going to be like the regulatory approvals, meaning that these drugs need to be approved depending to the country where you are living by different authorities. So in the US, it's the Food and Drug Administration, but every country has a different body who is looking at to approve the drug to be available inside the market. And then there's some post-regulatory surveillance. So you can see it's a long process, but I really want to, the reason why I organize this webinar today is to help you understand when you see news in the newspaper, what does it mean when there is like a new drug developed? Does it mean that I cannot get it today, or does it mean that there's some good news and there's some very good result, but there's still quite some time before there's something, this drug is available? So those are questions to understand, and that I wanted you to sort of like capture in this presentation, is that the cause of tinnitus is very it's very wide. Like there's multiple different causes, and it's really important when they study like that to understand for which causes this drug can be basically used. And so hopefully you could see some of you have been exposed to noise, and potentially you could have been a candidate. But then it's also important to be able to look at the time frame, in the sense that this drug will be good only if you apply it, or if you are basically getting it within 5 days after the onset of the symptoms. So it's important to understand, and it's important also to see that there's things happening. So it's important to have hope. There's things happening, things that basically done by researcher in order to find a treatment. But it's also really important to not have false hope, in the sense that I don't want you to feel that, oh, okay, it's going to be available tomorrow. But in the meantime, it's like, so, and it's where I would like to finish the presentation today, is like, what can I do today in order to minimize how my tinnitus is impacting me? And in order to do that, I would like to talk to you about what are the current treatment options that we know works and that can help you to basically better manage, but also to be less bothered by your tinnitus. And I would like to ask, like I did earlier, to start a poll, and just in order to understand how tinnitus has been bothering you lately. And so on a scale from 1 to 10, how much has your tinnitus bothered you over the past 7 days? Not bothersome at all is a 1, extremely bothersome is a 10. And then I just want to get an idea about where you are finding yourself. And then we will talk about strategy. I'm sorry, strategies that can help to sort of like reduce, because there's things that we can do today, and there's no need to wait for the drug to be available in order to be able to do something that works. So thanks a lot again for participating and in the poll. It's very helpful also for me to understand what's the distribution of so great. So I'm going to be able to end it now and share it with you. And you can see here that there's a huge variation about how tinnitus is currently impacting you. A few people are below 5, where I think it's possible. And the goal with any treatments which are currently available is we want to get to a 2 or a 3. So it's really the goal there. And I can see that there's a few extreme cases where it's a 10, and I want for anybody who feels that it's currently extremely challenging, and you feel that it's pushing you to a place where you don't want to be, there's options, there's things that you can do in order to make that the tinnitus is not as bothersome. And you can see that what I want you to also see is like you have the possibility to make it move and make it move back to where some of the other people in this room are, meaning that it's possible to decrease to initially to a 8, and then to a 6, and then to a 4, and then getting back to a 2 or 3. So thanks for sharing that. But now I want to talk about how we can get better and how we can improve. It's really important to see that it's a journey. So it's not going to change from a 10 to a 2 in one day. And it's going to take a little bit of time, but I'm going to talk about things that can make that we can get to a place where it's not bothersome. The first stage is generally awareness. It's when it can be extremely distressing, and when we feel we don't know what to do, and don't know, we just know that it's annoying and it's basically having some huge impact on our life. There's a phase in order to progress and in order to get into a place where the tinnitus is not bothersome. We need to go through stage 2, which we call allowance and more acceptance. And it's a stage where you're going to see that the more you're going to fight the sound, the more it's going to basically persist, the more you're going to perceive it. And if you get to a point where you allow the sound to be present, you're going to see that your brain is going to start filtering it. It's probably the hardest stage here to reach and to go through. But you're going to see that once you get through stage 2, acclimation is going to happen naturally. And what acclimation means is your ability to be able to put the signal that you hear in the background and allowing the signal to fade in the background in a place where you don't focus on it. In this curve, you can see ups and downs. So it's not really a linear pathway generally, and it's going to be a lot of good and bad moments. And generally, when we feel bad, it's a time where we feel that we feel extremely impacted and we don't know what to do in order to get to a place where we feel less distressed. But in this moment, I want you to remember that it's going to get better. When you have a bad day, if you have a bad day, please keep a positive mindset. Your positive mindset is going to be what helps you to get back up and help you to progress in this journey. There's a lot of up and down, but at the end, you're going to see that you get to a point, and we call that the achievement stage, where the tinnitus is a 2 or a 3. In the tinnitus, in the achievement stage, the tinnitus is present, but it's not bothersome anymore. And I want to reassure, and I want you to, for anybody which is in this room, I want you to know that you are all going to be able to get there. You are all going to be able to get there. And it's really important to keep that in mind. So now I just wanted to also ask, like, where do you feel you are, like in this journey at this stage? Let me find. Just to also have an idea for you, where do you feel, what stage? And sometimes we feel that we are between 2 stages. So, okay, but just in order to understand what stage of your journey you are in. And then you're going to see that depending on where you are in your journey, you're going to be able to apply different strategy. And this strategy are going to help you to get through the different stage. Great, so I'm going to share again. And you can see here that, so there's a distribution. So some of you are at the start of the journey. And for anybody which is in the awareness stage, I know that it's really challenging. It's really might impact your life massively, but I want you to know that there's a way forward. There is a possibility to move forward and to get to a point step by step where you will not be impacted. For people who are in the allowance stage, it's still, I know that it's probably one of the hardest time to be able to stop the fight. The more we fight and the more it gets back to us. But you're going to see that moving above this stage is going to allow you to start the habituation process and the acclimation. And for all of you who are in the acclimation stage, that's really well done, so that you have been able to get through already stage 1 and 2. But you're going to continue to improve. And then with time, you're going to be able to get to the stage 4. So really importantly, all of you are going to get to stage 4. It's a matter of like being able to find a strategy for you that helps you to get there. Now, we talk a lot about the auditory pathway, so it's like what we call the hearing brain. But I wanted to, more than the sound that is heard, it's often, and we saw that in some of the quiz that you answered, the poll that you answered, that is how we think about the sound that can have an impact on how we feel. The thinking brain is generally more like in the frontal part of so the frontal lobe that we call, where there's a lot of decision-making process. And the part that how we feel, so it's like deep inside the brain, we call that the limbic system. It's where we found the amygdala, it's where we found the hippocampus, and they have huge impact on how it makes us feel. So all these emotions, like sometimes we feel angry, we feel sad, we feel annoyed, all that is not exactly the sound, but that's how the sound makes us feel. And I want you to really, I'm going to try to see, to make you understand, help you to understand that here, the sound that we hear, by definition, is benign. It's just like inside the auditory nerve, and we saw it earlier, it's just like random activities which is happening in the auditory nerve. But depending on about how we think, and generally if there is fears about the future, and the more fear there is, and the more we are going to activate the limbic system, and then going to be harder to sort of like habituate. In terms of nervous system, some of you might have heard about the fight or flight response. And generally it's when we are in red here, so like when the red part of our brain is activated, we feel annoyed, we feel overwhelmed, we feel that, and it's a response which is here to protect us. So it's a protective mechanism that we, from an evolutionary point of view, has been developed over time to protect us when there's something which is dangerous around us. If a lion comes on your side, then suddenly you're going to startle, your heartbeat is going to increase, and you're going to be ready to run very fast. So it's going to activate your system. But the more fear there is, and the more this sympathetic nervous system can be activated, and the more it's activated, and the less we can basically allow the brain to habituate to the signal. So generally, the technique and the strategies that will help us to move forward are going to be strategies that help you to calm the nervous system and help the nervous system to feel in control again. And finding this balance is going to be an extremely important way forward to get back into a place where tinnitus is not bothersome. When we are in the fight or flight mode, we found generally that the sound is extremely loud. It's basically capturing our attention. And because it's capturing attention, it's basically make us increase the stress, so it's making us having some negative emotion. We feel angry, we feel sad, and the more sad we feel, and more we feel threatened by the sound, and the more we feel that the sound is a danger. And the more we, sorry, I didn't stop sharing. Hopefully you were still able to see the slide I was showing. But the more, so inside, it's very easy to stay in this negative spiral where the brain keeps thinking, keep checking, and we keep noticing it because we are in high alert. And we can basically keep being in this negative spiral, but the good news is like this possibility to get back into a positive spiral. And the positive spiral generally is the first thing that we need to be able to tell ourselves in order to basically feel reassured, is that the sound that we hear is benign. The sound that you hear is not dangerous. It's not dangerous and it's not important. And it's generally going to be the first thing that helps you to get to a place where the fear can be better managed. It's benign. It's just a stimulus inside the auditory nerve, which is transmitted to the brain. But it's not important and it's not dangerous. Then there's strategy in order to help to reduce the emotional reaction. More than the sound itself, it's often how it makes us feel. So if it makes us feel distressed, then it's going to basically extremely impacting for us. But here we have the option to sort of like understand that the distress is different than the sound itself. So the sound is something, it's basically, but we always need to recognize that it's benign. And at some point, and during it at Mind Year, we use a lot of relaxation exercise. We can basically turn off the alarm. So we can help the brain to turn off the alarm and get to a point where we can sort of like shift our attention away from the sound and get to a point where the brain is not focusing anymore on the sound, but focusing on anything in your life which is really important. And you get to reach a point where the brain is going to perceive the tinnitus as neutral, and you're going to see that it's going to fade into the background. And all of you here are going to be able to get to a point where the tinnitus is not bothersome anymore. So it's going to get to a 2. It's meaning that the sound is present, but it's not bothersome. And maybe once in a month, you notice it, but most of the time, it's not noticeable. You don't notice it, and it's not impacting anything that you are doing in your life. It's I know that we would love to stay always in the positive loop. And it's sometimes that we're swinging from negative loop to positive loop. And our role here at Mind is to help you, to give you the tool to be inside this positive loop and stay there until you get to a point where your brain is able to completely filter out the sound. So if you're interested, like today, we talk about research, and we see that it's very promising to see that there's new things happening. But you don't need to wait that there's drugs that cure tinnitus for you to start doing something. And that's really important for you to know. You can today already access, and there's treatment which have been validated scientifically, which shows that using paradigm and a suite of tools, you can already allow your brain to habituate and get to a place where you don't feel distress anymore. So it's really, really important. In our site, we developed an app that you might already have, And we developed like a group coaching program that you can join, where we can basically talk about the different strategy: cognitive behavioral therapy, mindfulness, relaxation, sound therapy, all these strategies that can help you to basically manage the symptoms and get you back into a place where you feel good. So we have like the group program. It's 12 weeks, and we have 6 group coaching sessions, and I can see that it's already the group coaching session are going to help you to decrease the fear associated with the tinnitus, really promote relaxation, improve sleep, and helping with grief, because often we see that we are missing something. We're missing something that was precious for us, which is silence. And because we miss silence, we have a difficulty to basically get to a place where we adapt to what we will call the new normal. Interestingly, our brain is changing all the time. Life is changing all the time. Nothing is like constant. And we're going to see that with time, you're going to be able to see. And once one of my patients told me that, I'm just the V2.0 of myself. I have a new version of myself. Doesn't mean that I'm worse, but I'm learning to be able to live with the sound and getting to a place where the sound is not distressing me. So I want you to know that there's things you can do, and there's things that you can do in order to make that your lives get back to normal. And these are like the results that we were getting with the program. And after 8 weeks, we saw that it was already 64% of the people who were getting to a place where the tinnitus was not as distressing. That's when they started. So it's not immediate, but after 8 weeks, you can already see massive progress. Just to finish a session, I just want you to know that there is hope. There is hope, and there's things that you can already do today. And if you need additional support, feel free to book a complimentary call with me. I will put that inside the chat. But feel free to book a call, and you can potentially join one of the programs. So either using the app or joining the group coaching session, where you can learn about the strategy in order to get to a point where tinnitus is not distressing. So thanks for listening today. I see that it's already 10:30 here. I'm going to answer questions now, questions that you have. But yes, like if there's one thing that I want you to remember from this presentation, it's really that keep in mind that there's possibility, there's things that you can do, and you don't need to wait for a cure for you to feel free from tinnitus. That's really, really, really important. And your mindset, you could see like entering this positive loop is going to be, and managing the fear, managing the worries are going to be extremely important. Of course, we saw during the pool that there's all the symptoms and all the things, sleep, which is also extremely important. Getting back a good quality sleep can sometimes really help in order to better manage tinnitus during the day. So I'm going to go through the question now, and feel free to write your question in the chat, and as I said, I will try to answer as many. For people who need to leave, thanks a lot for attending the session, and I hope it was helpful for you to understand what is the current status of research, but also understanding what you can do for getting better. Can tinnitus be cured after 25 years? So Mark, there's currently not a cure today. And again, but again, there's treatment and strategies that you can develop and use today in order to manage it and to get to a point where it's not distressing. And I hope that was my message of the second part of the presentation. I hope that you see that these things that you can basically do for getting better. Like it was a question about Prince, about what do you mean with the treatment needs to be administered within 5 days of the onset of symptoms? So yeah, for this drug, the AC102, if you wait too long, meaning that if the synapse is dying, then it's going to be hard after more than 5 days to be able to regenerate the neurons. It's the reason why, and generally, it's like the anti-inflammation or antioxidant of impact of the molecule, which is going to help it to recover and not to die. And it's the reason why, at this stage today, we don't have drugs which are, even though there is a clinical trial, which are helping regeneration of neurons. But for these drugs, it's more like maintaining existing neurons, if it makes sense. And it's the reason why it needs to be applied very quickly after nose exposure in this case. So now we have a question from iPad Pro. So I don't know the name, but what is the mechanism involved when audiologists claim that hearing aid can reduce tinnitus symptoms? How does it work? So it's a very good question. And generally, hearing amplification, the way it works is like it's amplifying sound around you. I don't know if some of you already noticed, but tinnitus is more prominent when you are in silent environment. So if you're in a silent room, the tinnitus is sound louder. However, if you're in a place where it's background noise, music, then the perception of the sound is going to be softer. And the reason here is like, so it's try to imagine a light, a light ball inside a dark room. Your perception of this light ball in a dark room is going to be very bright. But now try to imagine the same light ball during the day outside. Then your perception is going to be less bright. And it just means that the hearing aid here is amplifying sound and it's giving you access to some new sounds, which are then going to mask partially the tinnitus and help you to perceive it at a lower level. So I don't know if it helps, but the hearing aids are not doing anything to the tinnitus itself, but they are just amplifying sound around you and they help to reduce the perception, but providing a richer sound environment, if it makes sense. So I see some thanks, and thanks for people who attended. That's very lovely to get your comment. Thank you so much. Thank you. What do you suggest for sleep? Yeah, so sleep is I will call an animal on its own. Sleep is so important. And it's because during a night, our air cells are our body is regenerating, and meaning the metabolism helps to sort of like, it's good for our memory, it's good for, so we have toxin buildup during the day, which are going to be cleaned. There's new research which showing like actually the mechanisms that are working inside the brain in order to clean toxins that are secreted during the day during sleep, and that's very fascinating. So sleep is essential. Now, how do we basically help with sleep? There's different strategies there. One of them can be sound therapy, in the sense that during the night is going to be silence, and again the perception of the tinnitus is going to increase. When the sounding is increasing, then it can increase the amount of negative thoughts that we can have. We start to worry what I'm going to do, and this worry can then impact how we feel. So sound therapy can have an impact in terms of decreasing the perception, which can then help with the thoughts that are associated. Looking at the thoughts themselves can be very powerful. So there's something called cognitive cognitive behavioral therapy for insomnia, CBTI, and it's currently the strategies which has the most evidence from a scientific point of view for improving sleep. This is something that we provide through the group coaching session, and feel free to join because I think it's like something that you could really benefit from. That so CBTI is probably a key element of the overall strategy. And then lastly, there's what I think can be extremely powerful for sleep is also respiration or breathing exercise. Breathing exercise can be very helpful to calm the nervous system and help us to get into a rhythm where we feel more in control. And you're going to see that if you practice breathing exercise regularly, you're going to be able to help the parasympathetic nervous system to be more active. So, Gail, I think contact me also if you want to get more information. But it's these techniques, these things that you can do, and being able to get back your sleep is going to be probably a key element in order to recover and progress in your recovery journey. Thanks a lot, Rory. Thanks a lot. That's very appreciated about your support. The fact that you found the Mindy app is a great tool in managing my tinnitus. So it's the reason why we started this journey. We are here to help you. From a personal point of view, I started this project. My dad was severely impacted by tinnitus in 2006, so it's 19 years ago. And I felt at the time that we were missing tools that were able to support people. And it's the reason why I started the Mindy project now, more than started in 2017. So it's been a few years. It's been a journey to develop the app, developing the group coaching session. I'm going to also write here in the chat. This is in case you want to book a 15-minute complimentary call with me, feel free to do that here. And especially if you want to join the group coaching session, feel free to do that. And I'm happy to sort of talk more personally with you and identify what strategy and what treatment you could basically start today in order to decrease the distress that is currently created. Great, but thanks a lot for everybody. It's a lot. It was a lot. We talked about causes. We talked about symptoms. We talked about how the hearing organ works. We talked about promising results. And I just really think that it's promising result to see all this new development happening. And the things it's really, I know that one day there's going to be a cure that is going to be developed. I know that it will happen. It's not today, but today you still have strategies that are effective and are going to allow you to live with tinnitus in a way that is not impacting your life. And that, I think, is the most important thing to remember. You're going to be able to decrease the impact it has on your life. So I hope that it helps you to identify again on the strategy elements that or it's fruits for thoughts, and hopefully it helps you to sort of continue in your journey to progress to stage 4 where you will not be impacted anymore. So thanks a lot for attending this session. It was lovely to see so many of you. And please let me know if you are interested by this kind of research-oriented webinar where I can talk potentially about more research, all the research which are completed. And feel free to send me an email in case, or tell me in the chat also if you feel that this is a format you like, or if you would like other things, or if you would like me to talk about other things during this specific webinar, which are not it's really specific about one topic, but always very nice to get your feedback about this event. So thank you very much, everyone, for attending. Again, keep hope, and this is probably the most important thing. And know that, like, start engaging in one of the program, or either with the app, either with contacting me, and then you're going to see that it's going to help you to move forward. So thank you again. I will be sending this presentation. I will be sending an email with a link for you to be able to watch the presentation again if you feel that it's needed. And looking forward to talk to you at another point, or to see you again in another webinar. So keep well and take care of you, and then see you very soon. Bye-bye.